I'm doing a quick video on the inverse of sine function. So here we have the inverse of the sine function. All right, so check it out. The normal sine function, if you recall, starts off at 0, pi over 2. We have a max, 0, min, 0, as we go from 0 to 2 pi around the unit circle. We can also extend it in the negative direction as negative pi over 2 to negative pi. Now, when we want to look at the inverse sine function, we have to understand a few things about inverse functions. So before, with the normal sine function, we have the sine of some x, or some angle, and what we do is when we put that in, we get some y value up to 1 and negative 1, because that's where the unit circle goes. So positive 1 and negative 1 are the y values. As we start looking at the sine function, we have to understand that the inverse sine function has a few characteristics. One, to be an inverse, it has to be a 1-to-1. It also has to pass the horizontal line test. The other thing it has to do is they reflect about the y equal x axis. And finally, the domains become the ranges, and the ranges become the domains. So what was an x becomes a y value. What was a y value becomes an x. So in an inverse, what we're actually looking to do is we're finding the angle. So we're putting in an x, we're finding an angle. Or putting in a y, I should say, what is normally considered that y value, and what then does it do for the angle. Okay, so that's the inverse function. Normally, with sine, we put in, and I'll slide it down here a little bit. Normally we put in some theta, some angle, and what we do is we go up here and we get some corresponding y value. But what happens with the sine function is we're actually putting in a y value, right? We put in a y value, and then that corresponds to some x or some angle value in this case. So it's kind of interesting, pretty cool, as we study this a little bit more. So let's move on. Let's look at the picture now. So in order to make all of these things happen, 1-to-1 pass the horizontal line test, we must restrict the domain. So what ends up happening is we stop at pi over 2 to the right, and we stop at negative pi over to the left. Because if you recall, the horizontal line test, if I take this ruler, when does it stop meeting the horizontal line test? Well, right away. So what I have to do is I have to restrict that domain. The horizontal line test means it can't pass through there twice. If you recall, vertical line test went like this. Well, the sine function is a function because it passes the vertical line test. But now we have to pass the horizontal line test as well. So in that case, what we do is we put our ruler down this way, and as soon as it crosses two lines, then we know it does not pass. So if we restrict, now we see, oh, it passes the horizontal line test everywhere it goes. All right, so that's one cool thing about the inverse sine. Now, let's look at what it does for us in terms of math here. So, move on. So if you recall, the sine of theta equaled some y value, but now we're going to put in some y and get out an angle. So what does it do for us? It helps us find the angles. We use sine inverse to find angles, the thetas. Yes, let's look at some examples. Example number 1. Use the unit circle to find the trig values and angles. Okay, well here's our good friend, the unit circle. Hope you have yours. And so for sine, what I suggest you do is you take it and you label it. I'll do that. Pi over 2, negative pi over 2. The sine function, the inverse sine function, really only goes from pi over 2 to negative pi over 2. So it's only going to recognize these angles here. Okay? So that is the sine function. You might want to get a highlighter out and highlight that portion of your unit circle. All right? Okay. Now, the next part. is if we want to find the sine of pi over 4, we look at our unit circle and go, oh, well, that y value is root 2 over 2. But maybe I want to find out, well, what is the angle associated with that value? So I put sine inverse of root 2 over 2, and then it gives me the angle back out. You see? Kind of cool. Let's try another one. The sine of pi over 6, right, is negative 1/2. Therefore, the inverse sine of negative half should be 7 pi over 6. But if you know your unit circle also, then you know that if I go find negative 1/2, well, that's 7 pi over 6, but it also occurs over here at 11 pi over 6. So the inverse sign will only give you some of the answers. Now, if they're looking for an exact value, well, then the 11 pi over 6 would be more accurate of an answer, or a negative pi over 30. Because the calculator tells us if you put in sine inverse of negative 1/2, I challenge you to do it. Sine inverse, that's the second sine inverse button. It looks like that. And when you plug that in, you put in negative 1/2, your calculator will tell you that it's negative 30 degrees. So it's either negative 30 degrees, negative pi over 30, or 11 pi over 6. So remember, your calculator is only going to see negative pi over 2 to positive pi over 2 and give you those angles. So it's basically quadrants 1 and 4. Now, example number 2. Use your unit circle to find theta. Sine inverse of 1/2. Well, you get pi over 6 or 5 pi over 6 if you use your unit circle, but your calculator is only going to give you 30 degrees. Which one's more right? Well, it depends on what you're looking for. But the true value of the inverse would be pi over 6 or 30 degrees. If we're really looking at the aspect of it, we'll do that. Sine inverse of negative root 2 over 2. Well, negative root 2 over 2 is going to be, of sine, is in which quadrants? Well, that's either in quadrant 4 or in quadrant 3. Well, 5 pi over 4, that's in quadrant 3. So 7 pi over 4 is in quadrant 4 or negative pi over 4. So those two would be the more accurate answer given the sine inverse. However, 5 pi over 4 is not out of the realm because it does have an inverse or a negative root 2 over 2 as the sine value. Again, your calculator is going to give you negative 45 degrees. Sine inverse of root 3 over 2. Well, this is either pi over 3 or 2 pi over 3. Which one of these is in between pi over 2 and negative pi over 2? Well, that's pi over 3. That's 60 degrees. Look at your calculator. So, look at the context of the question. Right? Figure out what they're asking, if they're just looking for a sine value or are they looking for the inverse sine value, and how we can look into that further. All right? Hopefully that helped, and have a great night. Study hard. Thanks. Bye.